Question 704, binary search, and it's a easy Leetcode question. So basically they give you a nums of array and a target number, and what you need to do is write a function to search the target number in the nums array. If target exists, return the target index. If not, you can't find the target, then return -1. And you must write an algorithm with O log n runtime complexity. And if you look at this here and they give you the example, the target they want you to look for is number 9. And if you look at the number 9 here, you can check the index. It's index 0, 1, 2, 3, 4. So that's why the answer is 4 here. So 9 exists in nums and its index is 4, right? And then the next one is the nums array, and you need to look for a target 2, and then the output is -1 is because simply there's no 2 exist, so it return numbers, it return -1 in this case. There's some constraints here, and all integers in nums are unique, so nums is sorted in ascending order. This is super helpful. That hinted us that what we can do with this, and you can look at it, and this is the company asked this question multiple times in the last 6 months, and Amazon asked this question 13 times, and sorted in ascending order. And this is a really good question to use, especially it said all the algorithm must be less than O log n runtime complexity. And this hinted you need to use the binary search to look for the target number, especially for the sorted array. That's in order how you need to, in order to make sure that binary search works. Otherwise it's impossible in this case. So I'm just gonna show you the concept, like how you can do this, and -1 and 0 and a 3 and a 5 and 9 and 12, right? So this index 0, 1, 2, 3, 4, 5. So basically, for a binary search, if you have this even number, like you just let's say divided array by the middle point, because the array is sorted. So to make the searching more efficient, what it does is that you give a left index and a right index, and you start from the left index starting from here in the first value, and then the right index started from the last value. That's how you do the binary search. And then you start calculating a midpoint, and then if the target value is smaller than the midpoint number, then you need to search your answer on the left side of the array. And then if the answer is, which meaning that you need to move the, when you search the left side array, you need to make sure the R is you have to move R to 1 before the midpoint. Does that make sense? Because you can't find it because the target is smaller. And if it's the opposite, if what you're looking for is in the right, is bigger than the midpoint, it's on the right side of the array, so then you want to move the left pointer to m+1. So in that case, then you're going to continue this search, and then you're going to recalculate the midpoint, and then you're going to check if the target is bigger than the midpoint and not, and so on and so forth. In the end, you will be able to find the midpoint. The midpoint nums are equal to the target. If you are able to find it, and then you just need to return the midpoint index, which is the m here. Otherwise, you will just return -1 in this case, and basically indicating you can't find the answer. That's basically how binary search works, and you just continuously go on until you find the answer. And I will show you how to do this in code. And then you start with a left point, and the left pointer is starting from 0, right? And let me just recover this so you can see how it is. And it's like finding a number from 0 to 100. How do you find a number if guess the number more efficiently? If you tell me the target is bigger than 50, then I'm gonna start from the right side. I'm start from searching from 51, between 51 and 100. And if you tell me a smaller, I'm gonna looking for 0 to 49, and I'm gonna searching on the left side. Yeah, so the right side pointer should be equal to the length of nums array minus 1. That's the index, the pointer index value. So the condition for the while loop when you go through the entire binary search is that while left is smaller or equal to right, because you have to consider there's also a possibility that L is equal to right. What if the array only has one number, right? You have to consider the equal condition. So when they're equal, what I'm gonna do is I'm gonna calculate the midpoint for this array, and the midpoint index is right in the middle, right? So if it's in the middle, then I'll have to use the left pointer to plus the right pointer, and then I'm gonna divide them by 2. It's really not a divide, but it's like a Python get the integer of value for the division, and then you get the index of the midpoint, then you can compare the numbers. Basically, if the target number that you're looking for is bigger than the nums array's mid index number, like say somewhere here, if it's bigger, then I know for sure I need to start looking from the m plus 1 to the right side point. So then I need to move my left pointer to m plus 1 to here, and then I'm going to continue my search until I find the answer, right? Other condition is that if the target is smaller than the nums array's midpoint, then it's in the left side of the array, then I'll have to make sure the right side pointer is m minus 1. I'm going to move r to the one before m here. The other condition is that if the target equals to nums m already, right? Then that means we already found where exactly what we are looking for. So in this case, you just need to return midpoint, the index in this case. Otherwise, if I go through the entire loop that I cannot find anything at all, then I just return minus 1 in this case. That should be it for the code. If you think this is helpful, please like my video and subscribe to my channel, and I'll see you soon with more Leetcode questions. Alright, bye bye.